Good morning. I appreciate that introduction and greatly appreciate the museum and its education department for the invitation to be a part of this symposium. I've really enjoyed the first 2 weeks, and hopefully after the first talk today it'll pick up and be good again. A little audience participation to start with. Before this morning, how many of you had heard of the Oklahoma Mesonet? Raise your hand if you had heard of it. Oh, that's encouraging. How many of you would consider yourselves fairly regular users? Either you get on the computer or your smartphone and pull up the data. All right, quite a number. Do we happen to have anybody in the audience who is a landowner where a Mesonet site is located? This is a much smaller group, so it would kind of be the luck of the draw on that. Okay, one back there, and I know the Noble Foundation hosts a couple of our sites, so they could raise their hands as well. Does anyone know how long the Mesonet has been around, the Oklahoma Mesonet been in existence? Anybody want to throw out a guess? 20 years. You win the prize. We'll figure out what that prize is, because that's exactly right. We are celebrating this year our 20th anniversary as a network. Just a little bit of background. I'm going to spend most of this talk getting into the applications of the data, but I wanted to set the stage with some background. Oklahomans should be proud because we have a world-class network in the Mesonet. It's widely regarded as the best network of its type in the country and perhaps the world. Many others are jealous of what we have, come to visit and learn about it. As I said, it began in 1994. We call our launch date January 1st of that year. And it's a joint effort, as was said in the introduction, of OSU and OU, the state's two largest universities. It's been a really strong partnership between those universities, a grassroots type of partnership. The academic college's strengths at the two universities, OSU, of course, has the Ag School and Natural Resources. OU has a strong meteorology program in their College of Atmospheric and Geographic Sciences. So that's formed a very nice marriage between those areas of expertise. And we also house state agencies at the two universities. At OSU, we have the Cooperative Extension Service, which is the outreach arm of the Division of Ag at OSU, and the Ag Experiment Station, which is the research arm. And those are separate state agencies, but they all work together with the Ag College at OSU. And then our colleagues at OU have the Climatological Survey. Obviously, from its title, it deals with weather and climate issues in Oklahoma. So it's been a very nice partnership. And in fact, it's at the Climatological Survey where our Mesonet headquarters is, where we base our operations. So we're at the National Weather Center in Norman, south of the OU campus. We have 120 remote weather stations across the state. Pretty well distributed, at least one in each of our 77 counties. The average spacing, of course it's not on a perfect grid, but the average spacing is approximately 18 miles. So in weather circles, that's a fairly dense network that we have. This is a typical site. You will not find Mesonet sites next to airport runways or on courthouse lawns inside of cities or suburbs, but it's out in the countryside where we're measuring the true rural environment. And so many of our sites are on range land and pastures across our state, and this is a typical picture. We have a small fenced enclosure with a tower and a wide variety of instruments on it. And all of these landowners, by the way, give us free access, a long-term lease to use that piece of property and at no charge. So we owe them a big debt of gratitude. Just a few of the numbers, just to give you an idea of the scope. All total, well over 3,000 sensors are deployed across the state. A real key aspect of our network is that it's what's called real time. It's bringing in data not once a day or once an hour, but actually every 5 minutes throughout the day, 24/7. When you put that together, the number of sensors and that kind of reporting, it adds up to over 700,000 different weather and soil observations per day. We are out in the countryside, so we're solar powered with battery backup. We use radio communication, and I'll show you more about that in just a minute. And we have some backup storage in a small data logger or computer on the site. And we produce well over 60,000 products and data files every day, each and every day. So there's tremendous wealth of data and information that is cranked out by the Mesonet. This is a list of our sensors. Of course, when you think of a weather station, you're probably going to think about air temperature and rainfall first and foremost, and we certainly measure those. But there's a number of other things, and wind as well, but there's a number of other things that we measure that maybe aren't a part of all weather stations, such as solar radiation, soil moisture, and soil temperature. So it's a pretty comprehensive network in terms of what it measures. We place a lot of emphasis on quality assurance in our network. I won't go into all the details and the steps and the procedures that we follow, but we just don't grab the data and assume it's all right and put it away and forget about it. There's a lot of checking and cross-checking, calibration of instruments, a great deal of attention paid to quality assurance, and the end result is data that is of research quality. I did skip by this one. I was going to tell you more about our radio communication. We have quite a network of radio modems across the state that use line of sight to go from the rural Mesonet station to the nearest law enforcement drop, which could be a sheriff's office, it could be a police department, a highway patrol office, and we go there because once we get our data transmitted to those sites by radio, then we go across landlines using the Oklahoma Law Enforcement Telecommunications System, or OLETS. And we're very grateful to the Department of Public Safety for allowing us to use that network. It's a very reliable, high-quality network. It's the same network they use if you get stopped on the interstate for speeding and they radio in to check you out. That's the same network, but we have permission to move the Mesonet data across that. And a big deal for us is it doesn't result in any recurring costs. Once we get this set up, we can operate it at minimal cost. Okay, we have an extensive calibration lab, a variety of sophisticated instruments. Every sensor is checked out when it comes from the manufacturer. We don't assume it's correct when we first buy it even. We check it then, calibrate it, send it out to the field, and then bring it back periodically for rechecks of the calibration. So we're very careful in all of our record keeping on that. Probably what you're most interested in is how these data are used. And Oklahoma is a very weather conscious state, and we have a wide variety of application areas in which Mesonet data are used. I will not have the time, of course, to go into all of these this morning. I'm going to focus later on mostly on the first three because of the theme of this symposium, ag and water and fire. But I'll talk about a few of the others just briefly here to give you a flavor for what all we're involved in terms of applying the data. A very successful program has been the OK First program that reaches out to emergency managers across the state, county and state level folks that come to Mesonet sponsored training sessions to learn about how best to use the products. We have some tailored products just for our emergency managers. And any of those folks that use these products will tell you that in times of severe weather, it really makes a world of difference to them. So we're proud of that program. Another one that reaches all across the state is our K through 12 education. It's been a long-standing program, highly successful. A number of teachers and school kids use Mesonet data in the classroom. And the director of that program, Andrea Melvin, is here with me today, and she and I will be back at the Mesonet table later. So if you have any particular questions about the educational program, she'd be glad to visit with you. Research is another key area, ways that Mesonet data are applied. We've had, through the years, any number of very large research projects where scientists have come in from all over the country, dozens of them, to spend their money on motels and restaurants to help the Oklahoma economy, but really to conduct research using the Mesonet as the base of operations because there's no other network of its type. So we're kind of a magnet for large research projects of this type. And I wanted to mention a recent grant that just was announced a couple of months ago. It's a U.S. Department of Agriculture award, and you see the title there, and if you've been participating in this symposium the last couple of weeks, you see some words that we've seen: cattle, southern Great Plains, vulnerability, climate, land use. So it revolves around a lot of those same themes that are part of this symposium. It's very much a collaborative project with 4 universities involved, led by Oklahoma State, as well as the Agricultural Research Service of USDA and the Noble Foundation. So we're bringing the best and the brightest together to look at this in a very holistic way. The team's overall goal, you see here, boiled down, simplified, is to safeguard our regional beef production while mitigating the environmental footprint of agriculture in the region. And a very ambitious set of goals or outcomes that this team is looking at. This is a multi-year project, so it's going to go on for a while. But again, things that you've heard about the last couple of weeks: grazing and water use efficiency and drought planning, decision-making, soil and water quality. The federal government has recognized obviously the importance of these same topics and has awarded this grant to help this be studied in the region. Okay, just a word about weather forecasting, which is another one of the many uses of Mesonet data. I want to make it clear that the Mesonet does not forecast the weather. We don't do that. Don't blame us. Don't credit us. There's always jokes about the accuracy of weather forecasts. Our job is not to do that. That's the job of the National Weather Service, of course. But the National Weather Service forecasters will tell you that the Mesonet helps them immensely in doing their analysis and coming up with their forecast. You can just imagine if you have real-time data from 120 locations across the state, you can see what was going on 5 minutes ago. That's going to help a great deal in weather forecasting. We do take the National Weather Service forecasts and disseminate them out through our system. So we're a carrier of that information and provide it to the public, but we don't generate the forecasts ourselves. We do incorporate some of those forecasts into a few of our products. When we run models and make predictions and decision-making aids looking out into the future, we need to pull in those forecasts to help make those models be the best that they can be. So we use the forecasts, distribute them, but we don't produce them. And here's an example of on the Mesonet website, some of the forecast information that we do provide. You'll see graphs and tables and all kinds of ways of presenting it. And then we link directly to the National Weather Service page. This is their website where you can look up more details. And another way that they present it is a text version of the next 7 days. I tend to kind of like to look at this one. The maps are great too, but this kind of tells me day by day what they're predicting over the next week. But all that is linked up and available through the Mesonet website. And also I should mention that you can get radar data, real-time radar data through the Mesonet. Again, we don't have radar instruments out in the field. The federal government does. The National Weather Service provides that product, and we distribute it to the public. Okay, now to those 3 topics I mentioned at the top of the list: agriculture, water, and fire. And I'm just going to run through some examples here, kind of give you a taste of things that are out there in those application areas. If you go to the agriculture homepage on the Mesonet site, you'll see this, what we call Farm Monitor. It basically collapses a whole bunch of information onto one page in kind of a summary form. It doesn't have all the details behind each model and each product, but it's kind of a quick glance thing that some people like to use. One area, I mentioned that we measure soil temperature, and that can be an important variable when it comes to planting decisions. One of our products is, skip by, there we go, is the 3-day average bare soil temperature at a 4-inch depth in the soil, and that's kind of a key depth for planting of grain crops. And I took this off of the web, I think it was about on Monday of this week. So that's the preceding 3-day average soil temperature at 4 inches. And you can see that the state was pretty uniform, right around 50 degrees all across the state for average soil temperature at that time. Another variable that we measure is relative humidity. That has a lot of applications, but one can be in harvest conditions. The humidity can affect the moisture content of the grain at the time of harvest. So we produce maps and tables, and of course we can have quite a variation in the moisture in the air across our state, as you all know. Another thing that can come into effect, particularly with wheat, is late spring freezes. We're always leery of those as the wheat crop matures. Are we going to get damaged by a late spring freeze? And again, this was snapped last, I think, on Monday, but it reflected the hours below freezing at each one of our Mesonet sites over the preceding 48 hours. We're probably not quite late enough in the season for most of the state to be too worried about counting up those freezing hours, but that time is coming soon. And many times in the past, Mesonet data have been used to assess the severity of wheat damage on a statewide basis. We have a number of advisory products, models that we run for various pests, diseases, and insects. I just list a few of those here. We won't go into any detail, but for those specific commodities, we have products that are weather-based and that help farmers in decision-making. Cattle, of course, big in our state, and we have, just like we feel heat stress and cold stress, obviously the animals do as well. So we have a cattle comfort advisor. This time of the year today, they're going to be pretty comfortable, aren't they? It's pretty, not too cold, not too hot, but we've come through some cold spells this winter, and this is a map, I think, from February of the cold side of things, and you know, for each Mesonet site, it determines the level of cold stress that those cattle are subjected to. And you can imagine in July and August, it flips to the heat side of things. We apply pesticides, of course, in agriculture for insects and diseases, and we're concerned about having the right conditions for pesticide application. Sometimes temperature and humidity are important. If you look at the label on some of these pesticides, certainly we're concerned about wind drift when we apply, and of course it's never windy in Oklahoma, so we don't have to worry about that very much. And we have a neat product called the Drift Risk Advisor that's been set up, that's been developed just to use Mesonet data. And with this, you can look at the key parameters like temperature, humidity, wind speed, and put in windows in which you would like to apply the pesticide, maybe upper or lower limits. Enter those numbers. You can also select the wind direction that you want to avoid in your application. Maybe you've got the neighbor's tomatoes downwind or something and you want to be extra careful, so you would screen out the times when the wind would be from that direction, in this case from the west, and then press go on this model. It's very simple data entry, and then it comes back with a table using, this is a case of using the forecasted data, looking ahead. When does it look like most likely you would have a window of time to make that pesticide application, where the wind would be right, the temperature, humidity, whatever criteria you have set. So it's a very nice visual tool, and our pesticide applicators like it. Of course, wheat is big in our state, and a lot of our wheat is dual purpose, where it's used for grazing cattle as well as grain production. And there's a key growth stage called first hollow stem, where research has shown you better get the cattle off at or before that point in time, or you're going to suffer grain loss if you continue to graze. So this is a tool. It's a relatively new tool. It just came online this season, but it's proving very helpful to help producers know when to begin to scout for first hollow stem based on the historical weather. And we show this in map form. It's based on soil heat units, by the way. It accumulates based on soil temperature, the number of heat units that have developed. and that's been shown to be an excellent predictor of when you might expect first hollow stem to be reached. And it does depend on the wheat variety, the cultivar, whether it's early, mid-season, or late variety, and we allow for that in the model as well. And then we also show this in kind of a graphical form where you can see when it reaches various probability thresholds of achieving first hollow stem. So this is a newer product. It has a lot of years of research behind it, but it's just been rolled out this year, and we're real excited about it. So in a nutshell, not anything you didn't already know, weather drives agriculture, whether it's freezing or flooding, drought, wind. Certainly in Oklahoma, we're well aware of the impacts of weather on our agricultural production systems. And we think Mesonet is there to provide some really valuable information to help us assess that. Okay, turning now to water. Of course, you don't necessarily separate water and agriculture very much, but now to talk more about the water resources side, and probably the first thing you think about is rainfall. Certainly when we're analyzing droughts and floods, we talk about how much rain we didn't get or we did get. So I'm going to talk a bit about rainfall and soil moisture, which obviously is another water indicator, and then briefly about groundwater levels. So we slice and dice rainfall data just a whole number of different ways. We have many maps and tables that are there for any one of our 120 sites, just a wealth of rainfall information available on the Mesonet website. This is a portion of our web page that you would see in some of the choices that are there. For example, here's a whole cluster of recent rainfall accumulation, starting with the previous 1 hour on up to, I think that says 5-day, but it actually goes up to 30-day, 90-day, and so on. So you can pick a time interval of interest, you know, well, I think it's been really dry the last 60 days or the last week or whatever, and there's probably a map product there that you can look at to see. And I've just got one of these as a close-up as an example. I took this one off the web on Monday. So we did have, sympathetic to those of you in the Southwest and West, because you, once again, missed out on this one. But a lot of the state, as you know, got a fairly decent rainfall over last weekend. So this is a 3-day rainfall total as of Monday. So it captured that last weekend's event, and you can see the variability in rainfall across our state. Again, just an example of the many hundreds, thousands of information products that are there. We also take more of a climatological look. This is the last 365 days across the state, and it would be the departure from the 30-year normal or average rainfall that occurred over that time period. So again, no big surprise here. A lot of the western part of the state and some of the east and central too is certainly below normal on rainfall for the past 365 days. Some of those darkest areas are 6, 9, 12, even greater than 12 inches below normal. So it's been pretty significant. Again, we've had drought mentioned in the symposium in previous weeks, and it's something we're all very aware of. But this helps to quantify it and see it visually. Another product that we have, this one is really a stark look at the differences in the state. This is the number of days that we have gone in a row with less than 1/4 inch of rainfall. In other words, if it gets to 0.24 at your site on that day, it doesn't break the streak. But if it gets to 0.26, that does break the streak. So we just picked 1/4 inch as kind of a typical number. And again, I took this one off on Monday. So this was after those fairly general rains over the weekend. So a big part of the state, it's 0 or 1 day since they'd had 1/4 inch. It was a nice general rain in that part of the state. Unfortunately, our friends in the West, not so much. If you look at Goodwell there in the Panhandle, in the middle of the Panhandle in Texas County, that was 157 days. I guess it'd be up over 160 now. They've gone over 5 months without having a day with 1/4 inch of rainfall. And there are other sites across the West that are similar. So we don't get evenly distributed rainfall for sure. We also put it in tabular form. If you want to key in on a particular time period or a particular site, we have tables that do that. Here you see 7-day, 10-day, on up to the year to date, and I just clipped a few of our 120 sites. There's a long table there that has every one of those sites listed, so you can look up values that way. We also have monthly rainfall values by site. In this case, I picked the Cherokee site in western Oklahoma. And month by month, year by year, for the last 20 years, you can pull up the Mesonet rainfall totals for that site. One more rainfall product. It's really more than rainfall. These are what we call our monthly summaries. For any one of our sites, any one of the months in the last 20 years, you can pull up a summary table like this. You can just point and click online, print it out if you want to, just look at it. But this shows day by day for each day of that month what the max and min temperatures were, how much rainfall we got, what the wind speed looked like, soil temperatures, and so on. It's a great summary page if you like to file away records of that type. Or if you get in an argument with a friend about how cold did it get back then or how much rain did we really get, you can pull this up to settle that argument, I guess. Soil moisture is another one of our products. Obviously, it's tied to rainfall. It's going to respond to rainfall, but it is a separate thing to look at how much moisture is in the upper layers of the soil. Again, we have a variety of maps and different ways of presenting that soil moisture information. This is what we call percent plant available water on kind of a 0 to 100 scale. This would be in the top 16 inches of soil. So in total in that top 16 inches, where are we on a percent available basis? And again, you see differences across the state, obviously. This particular map is the soil moisture at the 2-foot depth. It doesn't accumulate for that zone, but it just says at a 2-foot depth, what does it look like? We also can look at graphs of soil moisture through time. This is Ardmore, the last 90 days. The red line there is the shallow soil moisture at a 2-inch depth. So you can see it varies quite a bit. You know, it's only 2 inches below the surface, so it's going to respond to a rain. When evaporation occurs, it's going to dry out quickly. So you see quite a bit of up and down with that as we've had wet and dry periods over those 90 days. The yellow or gold line is at the 10-inch depth. A little farther into the soil, it doesn't fluctuate quite as much. In fact, at Ardmore, it tended to stay fairly moist there, but you can see over the last month or so, it has declined. That yellow line has declined, meaning we're seeing drying at that depth. And then the green line is the deepest of the soil moisture, 2 foot down, and there it's been relatively stable. So there still shows moisture at that depth at Ardmore, but the area above that has been fluctuating more. So just a word as I leave soil moisture, a caution. Usually when we look at things like temperature and humidity and wind, if it's hot here, it's probably going to be hot 10 or 15 miles away. Not always when we have fronts come through, but we can extrapolate some of the weather variables a little ways away. You have to be more careful about that with soil moisture because, as you all know, soil type can vary just across the fence or even a few feet away. We can have topography differences. Soil moisture can depend on whether you're up high on the slope or down at the bottom where it levels out. Of course, the vegetation that's growing there is going to affect soil moisture. So we need to be a little bit careful in how far we run with that data, but still, given those limitations, it's a very helpful tool to indicate the overall water status. So that's why we measure soil moisture, and people find it of value. Just a word about groundwater levels. This is not an extensive undertaking for us, but in cooperation with the Oklahoma Water Resources Board, 4 of our Mesonet sites have co-located with them a water well that the water board has put in, and it's a groundwater monitoring well to measure the depth down to that water. So we have automated measurements every hour. We use the Mesonet communication system to bring that data in, just like we do our weather data. And we make that available on the website. This is Fitztown, is one of those 4 sites near Ada. I picked this particular one because this is a groundwater aquifer that really responds pretty readily to rainfall. So the green bars there, the vertical bars, indicate rainfall events, and that real tall one is like a 4-inch rain in one day. The blue is the groundwater level that's being tracked hour by hour, day by day. So you can see after that big rain that the water level in the well came up considerably, and then it tapered off over that drier period and recovered just a little bit at the end with some rain. Now, not all our aquifers in the state respond like that. If you pull water from the Ogallala in western Oklahoma, it's much more slowly fluctuating. It's a much deeper aquifer. But it does show you the value in making those groundwater measurements. Okay, a word about irrigation, kind of a term that ties agriculture and water together. I think we're all aware that certain weather variables will affect the rate at which plants use water. If it's sunny, high solar radiation, if it's hot in terms of air temperature, if it's windy, and if the air is dry, we're going to have a lot of evaporation and a lot of transpiration by plants. That's just intuitive. And by the way, we combine evaporation from the soil and transpiration through the plant and call that evapotranspiration, or you can think of that as plant water use is a simpler term. So we measure all these things, the wind, humidity, radiation, and air temperature with the Mesonet, so we can make estimates of that rate of water use. And we do that, and we have an irrigation planner where you pick your site that you're interested in, the crop that you're interested in, maybe enter a little bit about that crop, like the planting date, something about the maturity of it, and press go, and you'll get a table that accumulates the water use estimated by the Mesonet, the rainfall that has been measured by the Mesonet, and keeps kind of a checkbook balance of that. I think the best analogy is our checkbook. We put deposits in, we put rainfall into the soil or irrigation, we take our debits out of our checking account, and in this case it's that evapotranspiration or plant water use. So you can kind of think of it as a checkbook approach to scheduling irrigations. And Mesonet data make that possible. For the urban or suburban or anybody with a lawn that they water, an irrigated lawn, we have a simpler product called SIP for Simple Irrigation Plan. And this is a tool that can help lead a homeowner to better water management decisions on their lawn. So we have a website dedicated to that, and it leads with some fairly simple questions. It can lead a homeowner to understand when they should irrigate and how much water they should apply. And that's really what irrigation scheduling is. When should I do it and how much should I put on? That's what it boils down to. Okay, the final application area I want to talk about is fire and wildland fire management in our state. Again, Mesonet provides a basis for some really neat products in that area. And when we say wildland fire, we're talking about two different types. One is the one that we don't intend, the wildfires, which unfortunately we have from time to time. The other is the prescription fire, or the intentional burning for range management. And obviously weather data is helpful in looking at both of those. This would be an example of a wildfire. Hopefully that was not set intentionally with a prescribed burn, but that's one that would require emergency response. And those responders and the fire incident managers, believe me, they want to know where's the wind coming from, is it likely to change, what's our humidities like, and so on. So the Mesonet real-time data is of great assistance. And then, of course, here we have intentional torching to begin a prescribed burn for good vegetation management. Our fire danger model, it's a prototype, next generation model. It's at the cutting edge, in other words, of the U.S. Forest Service national rating system. This model was developed in conjunction with scientists in Missoula, Montana, and they were really excited about partnering with the Oklahoma Mesonet because this is the first place in the country where they've been able to use real-time automated weather station network like the Mesonet Other places they use 1 time a day measurements and plug that into their fire model. Here they could really push it to the edge with our real-time data. So it's been a good marriage with the federal folks and our model developers here. I'm just going to run through a few of the parameters. It's a fairly sophisticated model. It comes up with various outputs that are important to fire management folks. One is the burning index, and we'll just consider that to be a measure of the intensity of a fire. If one were to break out or if one is already there, it tells us something about the flame length of that fire. I think I've pulled down most of these, again, from Monday of this week. So at that time, and I think still today, we have fairly high fire danger in terms of the burning index across the state. Another one is the spread component. You can think of this as how fast would a fire spread if one were to start. Another one is the energy release component. There's not quite as much fuel out there now, so that's why this one looks a little bit greener. And then the fourth one is the ignition component. If a firebrand went out into a dry area, what's the likelihood that a fire would start and take off there and spread versus just die out? So all of these are important to fire managers, and the model, as I said, is fairly sophisticated. It is a statewide model. One of the things that goes into that model is the surface greenness, and this is taken from satellite data, which are fed into our computers. Guess what? A lot of the state isn't terribly green, or at least it wasn't a week ago. You can see, though, the forested area in the southeast part of the state shows up very well. And does everybody know what that yellow is sprinkled through sort of the midsection of the state? That yellow pattern that goes through west of Oklahoma City? That's our winter wheat belt. A lot of it is green, of course, so that shows up on maps like this. We have a fire prescription planner that's analogous to the one I showed you for pesticide application. Same basic concept. There's more parameters here, but you can pick upper and lower limits of different weather variables or fire products, talk about wind direction, and then in setting up your prescribed burn, you can make those entries and decide, looking into the future, when does it look like I can plan my prescribed burn? Of course, you still have to, you can't lock into that. You may think 2 days out it's going to be the time. You marshal your forces to do that. You get ready. The weather changes, the forecast changes. You obviously have to adapt your plans. But it is a very helpful planning tool for prescribed fire managers. Okay, how do you get at this Mesonet? It sounds like, from the number of hands that went up earlier, a number of you already know, but just to be sure, we have our homepage. It's very easy to remember, mesonet.org, O-R-G. And this is the hub where we fan out for all these various applications. So it's a great starting point to learn more about the Mesonet, or to go into the K through 12 or the agriculture or the fire or whatever it is that interests you. We have mobile access. We have a very popular iPhone app as well as Android app that are out there for free download, very popular. And then we also have a mobile Mesonet website with the URL of m.mesonet.org. But if you're either an iPhone or Android cell phone user, I'd sure encourage you to look into the app. You'll find it very helpful and interesting. We also do an electronic monthly newsletter called the Mesonet Connection. You can sign up for that. It's free on the Mesonet website. A lot of graphics, and it's not a terribly long newsletter, but it's always something of timely interest, and I think you'd find it something you'd like to subscribe to. We also have the Mesonet Ticker, as it's called. Most weekdays, there's an email sent out by our Ticker editor on various topics related to climate and weather, usually things that are happening then or have happened or about to happen, and in a kind of an interesting narrative. And the website for that is ticker.mesonet.org. You can sign up for it to be emailed to you automatically if you'd like. We also have Television presence. Got to get this right. There we go. Some of you are aware of the Sun Up television show on educational television, OETA, on Saturday morning. And each week there's a Mesonet segment there that, again, is looking at something that's been timely in the way of weather and soil data. And Al Sutherland, our ag outreach guy, is usually the one presenting that on air. We also have a social media presence. You have to do that this day and age, right? So there's a Facebook page as well as a Twitter handle for the Mesonet. So in the last 20 years, we have come a long, long way. And when we were talking about social media, real-time access to data on your iPhone, your Android, we've really come a long way from the early days. We were using the weather rock to help us measure the weather, and I hope you've gotten a little flavor of the technology here. We're beyond that now, and Oklahoma does have a state-of-the-art, a true world-class network that we can call our own, and we're very proud of it. I'd like to close by saying it's very much a team effort all the way. It starts with the landowners. They've allowed us to put these sites out into the rural areas to measure that true environment out in the state, not next to asphalt or a building, but out where it really matters. We have a talented and very energetic staff, great people that work with and for the Mesonet. We're grateful for them. We have a dedicated steering committee. We have 3 individuals from OSU and 3 from Norman that form the steering committee. Very collaborative approach. In fact, Claude, raise your hand. Claude Best, one of my fellow, where are you? Anyway, he's here to a member of the Mesonet steering committee from the OSU side, and that group works together very well and makes the policy and financial decisions that have steered the Mesonet for the last 20 years. We also have highly supportive partners, agencies, federal, state, local, that are right there with us and really make this thing go, and we're appreciative of them. And for funding and administrative support, we're grateful to the state legislature and the state regents and the administrations at both universities have been highly supportive of the Mesonet. So when we put it all together, what we're trying to do is make a difference in the state. It's for the good of the state and for its citizens. That's what drives us in the end. So it's those uses of the data, the applications, the stories that we hear about that really help to drive us, and I encourage all of you to be aware of the Mesonet, to see if it works for you in terms of the data that are provided, and I think you'll find it very helpful. So with that, one more reminder that we're celebrating this year, our 20th anniversary. In fact, I think there's a little clip in your goodie bag today that highlights the anniversary, so put that on your refrigerator and your feed barn with pride. And I'll close with that. Again, thank you for your attention. It's been a quick trip through, but maybe it generated some questions that you might have. Andrew and I, by the way, will be back at that table. You can't miss it. It says Mesonet on the front of it. We'll be there for sure at the 2 o'clock book signing, but also we'll probably be around there over lunch if you'd like to visit with us. So thank you.
Do we have any questions for Dr. Elliott? 1 second, let me get the microphone to you so we can all hear it.
Thank you. On your drift risk that you spoke about, can you use that, or do allergy and asthma clinics use that to help people? Because the other day, like, we had all that wind with the dust.
Yeah, the drift, I think you heard the question. It relates to that drift risk advisor, which is for pesticide application, but you're pointing out that the allergy outbreaks that we have in our state, the pollen and the other irritants, make a big difference in people's lives here. In fact, we had an add-on research project with the Mesonet back in it might have been way back in the 90s, I think, where a lady on the University of Tulsa faculty who's an expert in that stuff used Mesonet data in a research project and showed that some of those things that we respond to as humans come all the way up from Texas, as you might imagine. So there's long distance carrying of those. We don't have any particular air quality products that we run now on a routine basis. Of course, the television stations put out some of that information about the high, moderate, and low, cedar pollen or whatever it happens to be. But in terms of being related to the weather, absolutely, the humidity and the wind in particular have a big impact. And I guess we could try to use Mesonet to predict when the cedar pollen are going to erupt every year and give people a head. We don't have a model for that yet, but I know a lot of people that say, yeah, the cedars must be doing their thing because it hits them quick. But it's another good example of how weather has an impact on us for sure. We don't have any specific allergy products at this time, but who knows, the future might bring that.
We have another question right here.
On my app, in the middle of the radar screen, it's kind of a gray looking round spot. What does that represent?
I'm not a radar expert, but I think that's what they call the ground clutter. If you've seen, is it around Oklahoma City probably?
Yes.
Yeah, that is radar signals coming back from the buildings and the built environment. Again, if there's any radar experts in here, help me out because that's not my area. But that would not signify a big storm or anything, but it's just kind of the ambient environment associated with the radar signals.
Okay, we have one right here.
Does that sound right, Andrea? She's got her hand up, maybe. Okay, good job, she said, so it must be halfway right.
When we hear statistics on the TV about this is the hottest day since 1916, how reliable do I have to believe that? How was that collected way back a century ago?
Excellent question. We have the state climatologist for Oklahoma, Gary McManus, works out of the Weather Center and works with Mesonet, and he gets a lot of those questions and studies the historical records. We have our Mesonet history. We're very confident when we say over the last 20 years at our Mesonet sites, the highs and the lows and the extremes and the averages. But you're right, when they go back nearly a century, it can raise the question, what about the quality of the measurement? And, thermometers were still pretty good then. It's just that you had manual readings, and it's nowhere near the technology we have today. So I don't want to imply that you assume there's automatically a problem with them. It's just a different time, a different technology. You probably had excellent weather observers that were extremely conscientious in what they did. You probably had some that were, a little more lax about it. But it is good to ask those questions. I know one thing that the climatologists do on questions like that is to look at neighboring stations and see, well, did that show up around here too, or does that stick out like a sore thumb, which would cause us to question it a little bit more? Most of those observations are at least what it's called now is the Cooperative Observer Network. It's a nationwide network, as the name implies. They're cooperators, they're volunteers that are provided with the instruments, and usually they make one time of day readings. They have max and min thermometers and rain gauges that they read. And at least currently, I believe that is all kind of coordinated through the National Climatic Data Center. But it's a federal operation. But the cooperators could have been at an OSU research station, could have been a farmer, rancher, homeowner. It's just individuals that are part of that program.
We'll take one more question before we go into the break.
Thanks. So most of your forecasts go like 2 weeks into the future. What would you say your forecasts stack up against sort of products from the commercial meteorologists, and what would you need, or what would you wish for, for a forecast product for a longer lead time, like 1 month to 3 months or even longer?
Well, I know what you meant, but I'm going to correct you first. You said your forecast. I want to go back to we don't we don't do the forecast, but we provide them to people and make use of them. It is the National Weather Service that does the forecasting, and as we all know, the farther out you get, the less accurate they tend to be. You know, the meteorologists tend to be pretty good about what's going to happen tonight, less so about tomorrow, and then by next week, you know, it drops off, and there's very good reasons for that. I'm certainly going to defend them because they do a great job, and it's extremely difficult to predict that far out. But I guess with the context of this symposium with ag and water, grazing, cattle, it would really be great. I think the ranchers in here would agree with this, to know what they might expect for rainfall patterns over 1, 2, 3, even 6 months out. That would be great in terms of managing stocking densities and, you know, how many cattle do I want to try to run this season, and all those kinds of things. And you know, temperature is important too, but we usually have a pretty good idea, you know, based on the time of the year, what kind of temperatures we're going to see. But that moisture is a key thing, and if we could come up with better rainfall, and the farther out you go, it really becomes more of a climatological forecast, maybe based on past history, as well as things like El Nino and La Nina, and we heard some about that in previous talks. But and I haven't really tried to compare the federal government's forecast to the private sector. You know, I haven't really had much occasion to do that, but there are certainly private sector weather firms out there as well.
Okay. You know, the Mesonet's one of those tools that we at the Noble Foundation have used probably more so than any other one tool in the last, the 20 years that I've been at the Noble Foundation. And I don't know that the people in Oklahoma realize just how fortunate we are to have that network here in this state, because there's a lot of states that wish they had it too. So let's thank Dr. Elliott one more time.